All right. Good morning. Thank you for joining us for this morning's review and demo of our second sprint of the Spring 2025 work cycle, which ran from April 2nd through April 21st. Today we have David, Elisa, and Margaret to tell us about the goals for this work cycle and the work that was completed for the sprint. So here's Elisa to start us off for today.
Hello, my name's Elisa Pierce, and I'm working with the Daylight team. So this sprint, we focused on, again, maturing our components so that they'll be ready for connectivity at the end of this work cycle to get that whole life cycle and ecosystem fully presentable and demoable. So this first sprint, we focused on advancing our accessibility, and we also focused on responsiveness. We did some documentation as well and updated some README files. Really not much to show as far as what we showed last time, but what we do have is now a Figma file. And I'm going to hit it over to Chris, and he will demo what we have in a Figma file.
Yeah, thank you, Lisa. Again, not as Lisa was saying, it's been a lot of reframing in terms of like our approach to our Figma, or well, we got into Figma because we were trying to kind of build out the not only the functionality of each of our components, but we realized when we started talking about whether it was their inherent functionality or their inter functionality, it became difficult to just rely on words. And so we thought it might be helpful to create a design system in Figma, seeing that that's going to be an important resource for any party that's going to be using these components of our Daylight product. And so we're taking the atomized approach or atomic design approach, where we break down, and some of these pieces of UI might look familiar because it's basically getting down to the atomic level of our UI, and then using those smaller components to build what atomic design methodology kind of calls molecules. And so these are like, right, the assembly of some of those atoms of the UI that we were talking about. And what's helpful is as we get the design system almost a little ahead of our development work, we can start to provide some visualization of behavior. And this is kind of built in within Figma as like when you do the atomic piece, and then you indicate what is the behavior there at the molecule level, what is the behavior there. You'll get to start to be able to kind of showcase what we intend to do when we have all these components working together in concert. And what's nice is, right, talking about that visualization piece, once we get these on a localization level, right, we could start thinking about like, okay, great, we have that button that's placed throughout or scattered throughout our UI, but we want it to be using our specific design system or our brand guidelines, and things like that will be able to be done super easily starting from there. And then you can see like once we make a change at the atomic level, it'll kind of spill over and cascade into the other larger pieces. So that way for us, it's like, oh, actually we want a couple of drop downs in the search bar. We'll be able to add it here and then be able to show that across our various prototypes, which is one of our next goals, is to kind of build out the pages with the components at work. And so those things would also be interactive. So we just thought, yeah, this will be a great tool to kind of showcase functionality down the road to stakeholders, as well as to catch those functionality questions that are kind of assumed. But once you have something to look at, you could ask like, oh, where is that autocomplete, or where is that like erase, all facets selected feature that we were wondering about? It's like, oh, okay, that just gives us a chance to like think ahead and then develop in terms of like that, what we're kind of projecting there. So kind of exciting, small pieces, but again, it makes all the difference when we get down to much larger, more complex UIs.
Thank you, Chris. That's great. Really nice to see that. Next, we have Margaret. I don't know if you have, well, I think Margaret, you did have something to talk about. So I'm going to pass it over to you, Margaret.
Yeah, not too much to report. We did a little more work on some of the kind of back end stuff for Lark and Superskunk, getting those more in concert. The other thing, which I think is good to mention, is we continued moving forward with some of our discussions on how to get more complex nested metadata into both Comet, and I think eventually we'll be using that for Lark as well. So those conversations have moved forward. It was more focused on the technical implementation this time. So I think that there's a little more work to be done, but hopefully we'll be able to start the technical implementation of that in this next sprint. So I think that's one of the things that we're looking to continue moving forward with. And we had some of the conversations we needed for that this sprint. That's it for me.
Margaret, would you also want to talk about the ADRL light backend or daylight backend stuff?
I can mention it. Yeah, we've started having some discussions. Well, there's two pieces. One, we've started working on actually deploying it. Michael Craig on UCSB's side has been working on that and working through all the kinks of making that happen when it's not a part of the Surfliner monorepo, but something else in the Surfliner organization, getting that deployed and connected to everything. And then in terms of the infrastructure side, we've been having a lot of conversations about how we want to actually store the data in a way that will make it searchable and allow us to provide the API endpoints that the Daylight team needs without having a really large maintenance burden of having to maintain all of this connectivity between Solar or whatever else. So we've been talking about different strategies that we can use to keep it more lightweight and easier to maintain while still providing all the functionality that we need. And I think those conversations are still ongoing.
Thank you, Margaret. David, do you want to tell us about Comet?
Sure. So for Comet, we've been moving forward on the sort of the architecture and environments, sorting out something more like what we want our production setup to be. So we'll have production, we'll have a sandbox, which is like a mirror of production for testing and training and so on. Actually, I can share this diagram. And the idea is that this will eventually be the architecture for pretty much all the Surfliner systems, but we'll do review deploys when needed. There'll be a QA site. We're renaming this because it's really more used for QA than anything else, and that'll be automatically deployed. It's kind of like in a kind of traditional pre-agile environment, what would have been like a nightly build server. So it'll be whatever the latest code is will be on QA. Then production will be more stable and it'll be deployed manually when we think we're in a good place for that. And then sandbox at the same time will be the same code that's running in production, but it'll be used for testing and training and so on. So unlike, say, the Alma sandbox, it's not going to have all the data from production all the time, but it'll have whatever seed data or test data people need for whatever particular purpose they're working on. So that's a lot of that is done. Some pieces of it are still in progress, working out some of the kinks between Santa Barbara and San Diego environments and some issues with certificates and things. But Comet and Superskunk are there already, and we're going to move forward soon with Lark as well. The other piece of that is preview discovery environments. Actually, let me put the diagram back up. It was a little bit premature of me to close that. So there's been a consistent need from curators to be able to see what content is going to look like before it goes out to where patrons can actually get a look at it. And historically, the way we've kind of approached that would be to first load everything into a staging environment and then have to load it all again into production. So instead, we don't want to have to do that. What we want is you load it into production Comet, and you work on you do your QA workflows, your metadata, your binary files, images, whatever. And then you can publish to a preview environment, which is, for instance, would be like a preview ADR Lite or preview Surefliner or what have you. But that is not accessible to patrons. That's internal, and then you can see what will it look like, in its published form before in case you need to make any more changes before it actually goes to the real public-facing discovery. So we're still sorting out a little bit what exactly the requirements are for those preview environments, but we're working on that, and we're going to move forward on those shortly. We've also got a fair bit of just kind of essential Comet features and bug fixes. We've got file characterization, some fixes there, including calculating checksums on ingest, which I know has been a long outstanding request. That is now working. We're now working on file versioning and file replacement and some improvements there, both in terms of managing versions better and in terms of making sure that what people see on the screen represents the most recent version of the file. And then going forward for next sprint, we're going to start working on nested resources, as Margaret said, and continue to make some improvements around file versioning and replacement. But Comet itself, at least from Santa Barbara's perspective, is pretty close to feature complete. I know we're having some more discussions about what the San Diego MVP is, and we'll be pulling those features into future sprints. Yeah, I think that's it for Comet.
Thank you, David. Thank you again to Chris, Lisa, and Margaret for your summaries. At this point, we can take questions. If anybody has any questions, we can take them now, or you could ask once I stop recording. In fact, I think I'll stop recording now so that people have that opportunity to ask once the recording stopped.